Hi there. In this video, we're going to be going through kind of a fluids question, and I've kind of set up a picture here, but let me explain what's going on here. We have a fish tank, and it's 36 centimeters by 1 meter by zero point 0.6 meters, and so those are kind of my dimensions that I have selected here. Actually, that's exactly what's going on here, and so I've taken the liberty of converting my centimeters to meters already, and we want the water in the fish tank filtering through every 3 hours. We want all the water here running through the little filter that's gray with this little inlet tube or kind of input tube. And the tube has a diameter of 0.03 meters, which is the same as 3 centimeters in diameter. And so we want to know how fast does the water have to flow through this little input valve or the tube here into the filter so we get all of it cycling through. And really, this is a great opportunity to use the continuity equation, which is that the area of one section of a fluid that's flowing times the velocity, not the volume, is equal to the area in a separate section where the same fluid's passing through times its velocity there. And so really the idea is that we're having all the water in the tank flow through this input valve. And just for sake of ease, I'm going to choose to look at just this bottom surface of our tank. And I'm going to say that this is our A1. And it kind of makes life easy for us because we're just doing the length times the width here. And we see that A1 is in fact, oops, not sure what happened there. Oh, there we go. A1 is actually just 0.36 meters squared because we have meters times meters. And what's going to happen is the way we can kind of perceive the water in the tank flowing is this area itself is actually going to be kind of sliding up through the tank, and it's eventually going to reach the top, and that's when all of the fluid has kind of cycled through once. So we have this cross-sectional area that's flowing upwards. And I could have chosen a different wall. I could have chosen this wall over here, or I could have chosen different sections of it. But I just wanted to choose this one kind of for sake of ease with numbers here, really. And we also need to know the volume that is total that's kind of actually being passed through this inlet valve. And so we have volume is length times width times height. And multiplying these all together, we get our 0.60 meters and our 0.36 meters and our 1 meter, which doesn't really affect anything. We end up getting a value for the volume of right around 0.216 meters cubed, in fact. We could have said 2.2 if we wanted to really follow significant figures here. And we have 3 hours. And 3 hours, if we kind of cross out our units, we want to turn this into seconds, really. I'm going to divide by an hour, knowing that 1 hour is 3,600 seconds. That'll give us a value of 10,088 seconds is what we have. We have 3 hours for this entire amount of water to kind of cycle through the filter here. And so what I can do now is what we can do together is we can actually find V1 because we know that velocity is just distance divided by time, but our distance is actually this height here actually because that A1 is going up this height of 0.6 meters. So we have 0.6 meters divided by our time here of this 10,800 seconds, and that gives us a really small, very minuscule velocity of 5.56 times 10 to the negative fifth meters per second. Or in other words, that's the same thing as 0.0000556 meters per second. We just had to take this decimal and move it 5 spaces to the left. But this writing it in non-scientific notation is kind of clunky and awkward. And so really, we have our A1 value. We have our V1 value. We just need A2, and then we can find V2. We want to know how quickly the water is flowing in this little input tube here. And so that would actually be V2. That's what we're trying to identify here. And so to get A2, all we have to know is that the area of a cylinder, or a cross section of a cylinder, which is a circle, the area of a circle is just pi r squared. And so plugging into this, we have pi, and the radius is going to be half that diameter in red. So we'll have pi times 0.03, not 0.03, I didn't divide by 2. So 0.015 meters squared. And so I'm just going to leave it as this, and I'm going to actually take my continuity equation and we'll just plug in together. And so rearranging our continuity equation, we have A1 V1 over A2 will give us V2. Or in other words, taking these values and actually plugging in the numerical values here, we get a 0.36 meters squared times our 5.56 times 10 to the negative fifth meters per second over our pi times 0.015 meters squared. And following order of operations and making sure I keep the bottom together, we end up getting that this gives us a velocity of 0.028 meters per second, which is the same thing as 2.8 centimeters per second. So both of these are the same value. That actually is what the flow rate, that's how quickly the water needs to be flowing through our input tube, so that every 3 hours, all of the water in this fish tank or this aquarium is actually getting recycled and actually getting filtered for our fish. Thanks for watching.